Today, we'll explore linear functions on a graph. We'll cover key concepts related to graphing linear functions, including slope, slope-intercept form, point-slope form, standard form, and how to find intercepts. We'll also take a look at the domain and range of linear functions, giving you the tools to solve any problem on this topic. Let's dive right in. The slope-intercept form is one of the most important forms of a linear equation. Here, m represents the slope, and b is the y-intercept, which is where the line crosses the y-axis. The point-slope form is useful when you know the slope of a line and a point on the line, but not the y-intercept. The standard form is another way to write a linear equation. While it's not as immediately useful for graphing, it's great for finding intercepts. To find the x-intercept, we set y to 0. To get the y-intercept, we set x to 0. Let's explore how changes in m, slope, and b, y-intercept, affect a linear function. Increasing m makes the line steeper. Decreasing m flattens the line. Negative m results in a downward slope. Increasing b shifts the line up. Decreasing b shifts the line down. Both m and b determine the position and direction of the line. Let's look at an example showing how to find the equation of a line from 2 points. Let's start by finding the equation of a line that passes through the given points. The first step is to find the slope, or m, of the line. Remember the following slope formula. Substitute the x and y coordinates of the points into the formula. This simplifies to 4 divided by 2, which equals 2. So, the slope m is equal to 2. Now that we know the slope, we can use the point-slope form of a linear equation. We'll use the point, 1, 2, and the slope m equals 2 in the equation, y minus 2 equals 2 times x minus 1. This is the point-slope form of the equation. Finally, let's simplify the equation to slope-intercept form, y equals mx plus b, by distributing the 2 on the right side, and adding 2 to both sides. So, the equation of the line is y equals 2x. Great job! Now, let's move on to a more challenging example. This time, we'll find the equation of a line that passes through the point, 4, 3, with a slope of minus 1/2, and we'll convert it to standard form. We'll use the point-slope form equation, because in this exercise we are given the slope and the point the line passes through. Substitute the point, 4, 3, and the slope m equals minus 1/2 into the formula. Next, we'll simplify this equation into slope-intercept form. First, let's distribute the minus 1/2 on the right-hand side, and then, we'll add 3 to both sides to isolate y. So, in slope-intercept form, the equation is y equals minus 1/2 x plus 5. Finally, let's convert the slope-intercept form into standard form. We need to eliminate the fraction and rearrange the terms. Multiply the entire equation by 2 to get rid of the fraction, then, add x to both sides. So, the equation of the line in standard form is x plus 2y equals 10. Well done! Let's move on to a more challenging example that will test your skills further. Let's solve a more challenging problem. We need to find the equation of the line that passes through the points 2, minus 3, and minus 1, 5, and then determine its domain and range. First, we need to calculate the slope of the line using the formula for the slope. Substitute the coordinates of the points into the formula. This is equal to 8 divided by negative 3, or negative 8/3. Next, we'll use the point-slope form of a line to find the equation. Let's use the point, 2, minus 3, and the slope negative 8/3. Now, let's simplify the equation to slope-intercept form. First, distribute the negative 8/3 on the right-hand side. Next, subtract 3 from both sides to isolate y. We'll convert 3 into thirds and simplify. So, the equation of the line is y equals negative 8/3 x plus 7/3. For any linear function, the domain is all real numbers because there are no restrictions on the x values. The range is also all real numbers because the line continues infinitely in both directions. Thus, the domain and range of the function are both from -infinity to positive infinity. Now, let's compare this with the answer choices. The correct answer is A. Great work! You've now successfully solved a more complex problem involving linear functions and their domain and range. Let's recap what we learned today. We've seen how to use the slope-intercept form to describe a line, where m is the slope and b is the y-intercept. How to apply the point-slope form to find an equation when given a point and the slope. And how to convert equations into standard form to easily find intercepts. You've seen how changes in slope and y-intercept affect the position and steepness of the line. Visualize slope as the steepness of a hill. The larger the slope, the steeper the hill. The y-intercept is where the line crosses the y-axis, like marking the spot where you start climbing that hill. Remember, increasing m makes the line steeper. Decreasing m flattens the line. Negative m results in a downward slope. Increasing b shifts the line up. Decreasing b shifts the line down. Both m and b determine the position and direction of the line. Finally, you solved a question that tested your understanding of how to find the equation of a line from 2 points and determine its domain and range. Remember, for linear functions, the domain and range are typically all real numbers. Keep practicing, and you'll be ready to face any challenge that comes your way. We hope you learned something valuable today.